Hello, it's Mr. Robs here.
And Miss Bowie?
Right, and so we're going to look at solvent inequalities. And this one is saying y1 is less than or equal to y2. And if we look at our graph here, I know y2 is the red graph, so I'm going to make this red so we can talk about the red graph. And I'm also going to make this one green so we can talk about the green graph being y1. Okay, so Miss Bowie, when you look at this graph, and we're looking for the green to be smaller than the red graph. When I look at the graph, what's the first thing that you notice?
The point where they intersect.
Right, that's what I noticed too. And so I'm going to take this dotted line here, and I'm going to put it over top of the intersection to help differentiate between the two parts of the solution. I have the left side and I have the right side. And I know at 2 then, if it's 2, then I know that it's going to be equal at that point. That's when the two graphs are equal. But to analyze when is y1 smaller than y2, we should really look at all these coordinate points that exist on this graph here. And so this I know, if I estimate here, I know this is the coordinate 1 comma, like about 4.5. This is the coordinate 0 comma 5. This is the coordinate -2 comma 6. I'll do the same thing for the green graph too. Wow. Okay. And so why am I putting these coordinate points on there, Miss Bowie?
So that you can compare the y values at each corresponding x value.
So I'm looking at the y values, which is x comma y. It's the second part of the coordinate, because I want the y value, the green y value, to be smaller than the red y value.
Right.
So when I look at the y values this way, here I know that, here's another y value I can choose. Here is for x comma 3, 7, and the red version will be down here at 3.5. Right, so when I start to analyze this, I look at my y values. So here's my y value. I have 7 and I have 3.5. I want the y green value to be smaller than the red value. So is that green value smaller than this value?
No.
No. So I'm going to put an X for it's not being true. I know here they're equal, so I get an equal sign.
Yep.
If I look at this graph here, the green value is 1, the red value is 4.5. Is 1 smaller than 4.5? Is that true?
Yes, it is true.
So then I'm going to make a little check mark here saying, yes, it's true. Let's look here at this 0, and x is 0. The red value is 5, the green value is -2. So is the green value of -2 less than the red value of 5?
Yes.
And that is true. If I looked at 1/2 here, this y value versus this y value, this is smaller. So again, it's true. So I think all these values it's going to be true for.
Right, because if we were to extend the line,
right, if this green line be extended,
right,
it would always have y values that are smaller than the red y values.
And the green line would always be below the red line.
And so when I look at this sign, when I think about inequalities, I think about when is the green line below the red line.
Right.
Okay? So I know it's not, on this side is not below. And so my solution then is going to be starting at 2, going in all these values here. Including 2 because there's an equal sign here, so I'm going to shade it in. And so now our solution, how do I describe all these values?
They are all numbers that are less than or equal to 2.
2. And these are my x values.
Right.
And so the question is asking for is about y values, but our answer tells us which x values describe the y values as the green ones below the red ones. Okay, let's try a new problem with the table. Okay, so now, here's another scenario here. Now we have a table to look at. But again, we're told We have y1, which I'll call blue, which I know it's purple, but I don't have a purple pen. We'll call it blue. And we have the black values here for y2. And so I'm going to consider what's going to happen. This is saying when are the y1 values, when are the blue values smaller or less than the black values? So if I look here at negative x being negative 5, is 8.5 smaller than 4.5?
No.
No. So that's no, and I'm going to put an x here, false statement.
Right.
At this x value of negative 4, is 7 smaller than 5?
No.
No. That's no. When I go to negative 3, and here's always a key point. This is where they are equal. I can see they are equal. And so I'm going to put a little equal point. This is the turning point, the transition. Something interesting is happening here. So now if I go to this x value of negative 2, is the blue value 4 less than 6?
Yes.
Yes, hooray! Success. Okay, so I'm going to say, good job here. I look at negative 1 as my x. At negative 1, is 2.5 less than 6.5?
Yes.
Yes. And I can see the rest of the pattern here, that it is good for all these values in this direction. All these x values make this statement true.
So that means that all these x values here are solutions to the inequality.
And on my number line, I'm going to put a circle at negative 3, and I want this direction, all these values here. All these values make this statement true. At negative 3, is y1 less than y2 at negative 3?
So is 5.5 less than 5.5?
No, it's not. It's
Right.
equal to. And so I'm going to leave it open this way, because this is our turning point.
To indicate that negative 3 is not a solution.
Right, it's not a solution. It's pretty close to negative 3, I'm guessing, but all the way up to, but not including negative 3.
Right.
Okay, so we have to make sure that we read carefully what this question says and interpret it on our table or interpret it on our graph.